everyone. A very warm welcome to lesson 2 on credit card fraud detection and prediction project. In today's session, we are going to explore credit card fraud dataset using a citizen data science tool, which is an enterprise level tool for data science or machine learning, which is known as Data IKU. So we are going to use Data IKU 5.1 Data Science Studio product in order to explore the credit card fraud dataset. We are going to plot certain graphs on it. Using these graphs, we are going to identify what all factors are influencing each other. And then we are going to test various models on the dataset so as to get an insight what kind of data is available and what existing algorithms can be used to solve the problem. Then we are going to explore performance tuning mechanisms, and followed by we can work out on other individual algorithms and combinations so as to identify the credit card detection and prediction and prevention with an effective approach. So let's go ahead. To go ahead, today we are going to make use of Data Science Studio. So the credentials I have already shared that on your mentor cards. So you can quickly get access to dataiku.com, Data Science Studio, and you can log in with this ID and password. So we are going to open that Data Science Studio. So once your guys are logged in, you need to use your database here. Now here, you can quickly log into your Data IKU account, and once you guys are ready, you need to wait for my instructions. We will proceed further from here. So in the previous session, I would like to quickly give you a quick brief of what all we did. So in the previous session, we started gathering the data. The data I have already uploaded on my web server 13.232.226.32, where creditcard.csv data is available. Now here, as you all can see, we have quickly got credit data.columns, and we have listed these columns over here. So we have information about time. Then we have certain variables, approximately 28 variables are there. Then we have the amount information and the class information. So class contains two categories. One is a no credit card fraud, and second one is a yes credit card fraud. Okay. So 0 is represented when the transaction is authentic, and 1 represents where the transaction is considered as a fraud transaction. So we have this data available. We have specified the data here, wherein you all can see we have got a lot of columns and a lot of rows available over here. Now, so tentatively we have, this is the data size which we are going to perform processing on, 28,4,807 rows via 31 columns. Now, we got certain information like time, amount, and class, and we got unique values over the class. So when you got access to unique values, you can see that we have a class 0 and class 1. 0 represents an authentic transaction and 1 represents an unauthentic or a fraud transaction. So now we need to identify the patterns. We need to identify what all variables are associated to each other. So here what we did, we performed a plot on credit card data, and against the amount we have plotted. So we got the class and we got the amount, and we got a fact that with respect to the transactions, as you all can see on my card here, let me just annotate that for you. So here is the fraud transactions, and here are the authentic transactions which are displayed to you. Okay, so authentic transactions, you can see that vary in various high ranges also, but fraud transactions are done on the amount lower than $5,000. Okay, so this was a quick insight we got when we started working on this data. Now, what we will do, we are going to perform. First of all, we need to identify the influencers. What all variables will be treated as independent, and what all variables will be treated as dependent. That's what we need to start with. So I'm going to add a new code cell here on my shell. Let me just connect the script code. I have already shared the script code with you all. If you want, I'm sharing the link via chat box to all of you. On Mentor cards, the script code is already available. So in case if you want to access that from there, you will be able to access that. Now, so let's run all the cells. Once we run all the cells, we are going to get the data downloaded, followed by a scatter plot will be made here. Okay, so now here, so the data is being downloaded as of now over this cell. So yes, we got the data, we got the number of transactions. Post that, we got the array, we got this graph running. Then in the previous session, we also started with calculation of correlation matrix, which you guys already understand. And we plotted a correlation matrix over here. There is one more option which you can plot over here, which is a Seaborn map. So you can have a beautiful correlation matrix using Seaborn. Okay, so you're going to import Seaborn API, Seaborn as SNS. Okay, you can call it as SP. Let's import that. So Seaborn is a library which gives you access to create high quality heat maps. Okay, so what we're going to do using SP, we're going to call a function known as Heatmap, which you guys are going to draw today. So when we run this Heatmap, since we have 31 columns, we are going to represent them with a very nice color matrix. So this is going to plot rectangular data as a color encoded matrix. Okay. Now, when you run this heat map, you're going to pass your data dot correlations. Along with, we are going to use certain options, like we are going to use annotations. Annotations would be an option which will let you see the numbers over a scatter matrix plot, so that you can observe the influencing variables better. So let's go for it. Let's draw that. So I'm going to use sp.heatmap, and I'm going to call a function over here, and this is going to be our data.correlation. So I believe we have stored our data in the data, sorry, it's known as credit data. Okay, so we are going to call it as credit underscore data dot correlation. Credit underscore data dot correlation. So when you plot this, you're going to get a heat map somewhat like this created. So now you can see that since you have a lot of observations, here we have a class, here we have the numbers, a Seaborn plot, somewhat like that has been created for you. Now what I want, I would like to put annotations on. Let's put annotations is equal to true, so that I'm going to get the numbers over this graph also. So let's say we're going to get a graph with numbers pointed on it. So as of now, you can see that I'm not able to observe this graph properly due to its height and width issues. So what I want is, I would like to make a larger graph. So to do that, what you all can do, you can quickly make use of matplot library. So let's import matplotlib.pyplot. I believe that we have already imported in the previous cell. Let me just quickly check back. So you've got stats model and you've got matplotlib.pyplot as PLT. Okay. So using this PLT object, we are going to create subplots. There's a function known as subplots, and using these subplots, there is a option which you all can use here, and this option is known as the figure size. Okay, you can create a figure, and you can define a property known as figure size in this, so that you can enlarge the size of your heat map which you have generated using Seaborn. Okay. So let's see. So there are certain parameters which you can quickly explore over here, at how you can use them. It's going to return your figure, and I'm going to pass a value known as figure size within this. So let's call it as figure size. Okay, I believe this is how you can pass your figure size. And let me just quickly create a figure size of 10 cross 10, let's say. And I'm going to save that into my figure and axis. So once you run this subplot, you're going to get two values as output. One value will be the final figure that will be stored into figure, and one you're going to get axis. So this axis information you can pass in your heat map, and you're going to get a better graph. So this time the graph which you are going to get is going to be 10 cross 10 pixels wide. So now you can see that this seems a little better as of now, but I believe we need to increase the size a little more. So let's say I'm going to make a plot approximately 20 in the width wise, so that the numbers are clear to us and we will be able to identify, okay, still this doesn't look good. I think we need to increase up to like 40, let's say. Okay, yeah, here. So now this seems a little better. Okay, and you have these parameters with respect to amount, which is listed over here, and you have got certain correlated variables which you can observe with the color matrix here. So guys, as you all can see, so we have the amount here and we have a class here. Okay, this is the class which we want to perform a prediction on. Now with respect to plot, let's see what all are considered as influencing variables, highly influencing. So with respect to the data which I currently observe here, I need to get some highly influencing variables in case if there are any. So as of now in the data you can observe, over the class there is no highly influencing variable available. We do have certain influencers, but they also influence like 9%, 13%, okay, 2%, 15%. This is the influence rate of class with respect to other variables which are available. So this means you got to know that with respect to the current credit card data, there is no single influencer. So now we need to proceed to the next stage so as to identify how individual variables are correlated to each other and how they are plotted. So let's quickly observe that. Okay. So now what we're going to do, let me just clear that, and I'm going to make a plot of the data frame which we have got. So we have got this data frame known as credit data. And if you quickly observe the head values, let's say top 3 values over the head, you'll quickly get back, okay, these are the data available. So I'm going to make a plot here. So I'm going to call, let's plot all the parameters which are available in credit card. So I've used this data frame. Sorry, this is credit data.plot. Okay. So now when you run this, you're going to get a graph with all the individual variables from V1 to V28, along with time and class and amount. They all will be plotted on a graph. And let us quickly observe how we are going to get a line plot which is going to show us the relation among how the data is distributed and all that stuff. So I'm just trying to plot that here. So you have got certain variables here. As you can see, there is one specific variable which is blue in color, which is time. Okay. And I believe we have amount. Sorry, amount is the data available over here, which you can quickly observe here. Here is the amount which is listed here, this color, and you have the class values 0 and 1, which are available here on this line, and then you have the time value which is represented by this image. Okay, so let's see. So with increment to the time, you can see we are not able to observe very small values which are plotted over the graph. Since we have these many values, we are not able to get these lines. So as you already know, since the data is not standardized nor it is normalized, so we are not able to observe this data well. Okay, so let's go to the next step, wherein we are going to normalize the data in order to perform the analysis. Okay. So in order to perform the analysis, what you can do is you can normalize the data using either standardization, using the standard score, or min-max scaler, min-max scaling. Okay. So I believe you all remember the formula for min-max scaling, which I have already explained in the previous videos to all of you. I believe you all remember. So the formula is y normalization is equal to, x normalized is equal to x minus x minimum divided by x maximum minus x minimum. Okay, so this is what you guys need to calculate. So first you need to get the x values. Okay, so x values could be your data value. So since we have credit data, we need to create a normalized credit data. So what am I going to do? Let's do it this way. X is going to be your credit data. Okay, and I would like to quickly print X out of it once I save it. So you can see that the credit data is now saved into X variable. Now what next you need to do? You need to quickly get the minimum value. So X minimum is going to be X dot minimum. You can quickly call the minimum function. Let's say get the minimum value for each column in credit card data. Okay. Then you're going to get the X max value, which is going to be X dot max. So get the maximum value. Get the maximum value for each column credit card data. Okay. Now let's quickly put that. So we are going to calculate X normalized, which is going to be X minus X minimum divided by X max minus X minimum. Okay, and now we're going to get the normalized value. So I'm going to get top 3 normalized values, or if you want to observe all the values, let's quickly have a look. So we are going to push X normalized. So once you do normalization, so as you all know, now your data will be standardized or transformed between a range of 0 to 1. Okay, so minimum value is going to become 0 and maximum value is going to become 1 for each column. Okay, I believe this is clear to everyone. So X normalized, X norm is a transformed data. Which ranges between 0 to 1. I believe this is clear. So now what am I going to do? Let's plot the normalized graph. So I'm going to use xnorm.plot and let's run that. So now once I run this, let me see what we are going to get. So once the data is normalized, so all the values are being calculated. I hope all the participants connected are able to follow. Are you guys running this? Dhruv Singh Pal, Apar. Okay, great. And Chavi Gujral. Okay, so guys, here also you can see now you have got this X normalized plot. But again, the issue is you're not able to observe the graph since the data is big. So again, you need to put the figure size so that you can get a widened graph. Okay. So when it comes to real-time data, you have a lot of observations. So mostly you need to provide the information so that you can set the graph and all. So now let's see. So what we're going to do, let's quickly put plt.subplots again. Okay, plt.subplots, push a figure size, and to push a figure size, let's take 30 cross 10. Let's try with that. And I'm going to get 2 variables in return, figure and axis. and I'm going to call, okay, so we are going to get that x dot plot. I need to check the access for that. Okay, so this function already has a figure size in it within the plot, so we don't need to create that extra plot. In the xNormalization.plot function only, we have the figure size parameter available, wherein we can pass the values like 30 cross 10. Earlier, it was not available with the Seaborn API, Seaborn library, but we do have that in the matplot library. So now we are plotting a normalized plot just to observe how the figure looks, just to have a quick idea about how all the parameters are plotted on one single graph, and does it has any relationship among the variables? Though it does not have, because we already got that with the correlation matrix. We already got that class does not have any influence with any specific variable. There is no highly influencing variable, but just for the sake of visible surety, also we are trying to make the plots, and we are testing that. So all the values are going to be plotted on the graph. So now again you see, I think we need to create a very big plot, somewhat like let's say 300 or so. Then only we are going to get that visualized over this. So a plot with 300 size would be a very big plot. So I just passed 300 just to make sure that the graph should be plotted and I should be able to visualize it easily. Since we have very high data, that's why we are getting all the values plotted on a graph, and it becomes quite suffocated kind of a graph. Hence, we have specified 300 width for the graph so that we get a very big graph. Okay, guys, by the time this graph is loaded here, let's quickly grab the data and we will quickly push that on our data IKU server. Okay, so let's grab the CSV file from where we need to get our data. You all can use this URL, creditcard.csv. I'm sharing the link with you on chat. Okay, you can have this. And we'll quickly get back to our data IKU by the time this graph loads up, because it is taking a couple of minutes to load the graph. By the time on data IKU, which we have previously opened, we're going to get started with a new project. Let's click on new project. I think you all are comfortable with data IKU already. You already have done house price prediction project over this. Now we're going to start with a blank project. Let us just quickly specify the names of the project. So this is going to be my DS credit card project. And I'm going to create a project over it. Okay, guys. So this is our dashboard, which I believe you all are pretty comfortable with. So one question, the graph which we have normalized now, what its significance? So the significance of the normalized graph is just to observe all the parameters which are available in the data, just to identify if there is any relationship or not with the visual representation, with the visual graph. Though we have already checked this relationship using correlation matrix and the Seaborn map, where we already identified that class is not influenced by any other parameters. But there are different parameters. Just to show you, we had certain parameters over here. Let's say, so here we got the plot. So now you can see that since the plot is pretty big, you can observe that financial data has a lot of information. So this blue graph is something like time, which is generally increasing. Okay. These are your amount, the number of transactions which has been made. Okay. And other parameters which are available in the data possess a very high value. Okay. So now we need to identify what all these values are with other individual graphs and what all parameters are we will be able to use in order to perform the prediction and all that stuff we need to do. We need to check. Okay. So what I was saying we have already plotted a graph here, which is the Seaborn graph, this one. So this Seaborn graph was already used to identify if there is any influencing variable or not. So you can see that amount is highly influenced by V7. Or you can also say V7 is a factor which is highly influenced by amount. Similarly, there are other highly influencing parameters with respect to amount. Okay, this one. Amount is also highly similar with V20 and 34% influence is calculated or is identified on the factor V2. Okay, but our objective is to score the class. We have to identify the influencing variables who can predict the class. So here you can see that none of these are highly influencing. Neither time, neither V1, neither V2, V3, V4, none of these variables are influencing the class. Okay. So we also tried to make a plot similarly just to plot all the values in order to see the value range of these of the parameters or the variables which are available in the data. Okay. Now, so what we'll do, let's just get back to the visual tool where we are going to perform the analysis and we're going to get a little idea about what all is happening in the data. Because the data which was given to us, it was not original. It was already converted into numbers and we don't have much information about how it was collected and so on. That's why we are plotting the graphs and trying to understand what kind of data is available. Okay. And what are the value ranges and all that stuff. So let's come to credit card project on data IQ. Import your first data set. And we have got this URL 13.232.226.32/creditcard.csv file, which we are going to quickly upload here using HTTP protocol. So we have gone to HTTP, we have specified the dataset file, and we go to the bottom. And here we are going to quickly click on test. Okay, so you already know how to quickly import your credit card data on data IKU server. You can test that. Once you guys tested it, you can observe we have got 31 columns in the data. Okay, and this is going to be known as credit card data set. Okay, so here is the name of the data set which I have given, credit card _ data set. I'm going to click on create and the data will now be ready for analysis. Okay, here. So you can see that already all the variables which are available to us are already converted into numbers. Okay. The data is already converted into numbers. And now we are going to plot these graphs and try to identify potential information out of it. So to start analyzing, we quickly go to the flow. Okay, correlation matrix you have already done, which you have identified is of does not have any influencing independent variable, which is influencing our class outcome, class dependent variable. So we go to the data set here on data IQ, right click over here, go to lab and get started with quick modeling, just to identify what equation may work well in prediction or class in prediction of the objective class. So we go to quick model, we go to prediction, and we will go to the class variable, which is the last. So this is the outcome which we would like to predict, and we will go towards expert mode, where we are going to performance tune our algorithms. Okay, and we may be writing our custom models also, so as to get the highest accuracy. But currently we would like to identify, instead of going for writing a new algorithm, let's just test that with the existing algorithms, what all algorithms are available and which algorithm may suit the credit card data best. Okay, so we go to export mode. We're going to choose existing algorithms. So let's call it as existing, or let's call it as prediction on our credit card data set. We go to create. Now, once we are here on the create, you can see that the target which we have selected is a 2-class classification. Okay, and we have selected the outcome as class. So it is a 2-class because class 1 is 0 and another one is 1. So now you can quickly observe the number of records which we have class 1 is very minimum. Okay, so this problem which you are seeing that 0 is 100% and 1 is approximately 0%. So this is known as a problem of class imbalance. Okay, this is known as class imbalance problem, and it is very difficult to make a model when your classes are imbalanced. When you have all the data available for all the data is available for authentic transactions and a very few data is available for unauthentic transactions. Okay, so let us just quickly go and plot a graph over the class so that we'll observe how many values are there. Okay, so before proceeding to modeling, let's do one thing. Let's again go back to the flow. You have your data. Click on your data. Okay, you can double click on your data. Once you double click on your data, you're going to get your data set open here, which has approximately 10,000 rows and 31 columns. So one problem is we have not got the complete data uploaded over here. That's why in data IKU we got one problem, that all the data which we have got is only for problem zeros. Okay, so now you can see that we can quickly go to class, you can go to analyze, and you can see that we only have 38 transactions. We only have 38 transactions for 1 and 9,962 transactions for 0. Okay, which is approximately 0.4% of the data. So this is a high class imbalance. Okay, are you all able to understand? The data which we have got here is highly imbalanced. So authentic transactions are 9,962 and unauthentic transactions are only 38. So let's do one thing. We'll do one thing. We quickly go back to our previous script which we were writing. We are going to modify the credit card data frame a little. We are going to sort that in descending order so that we have more values of 1. So in the previous cell, I'm going to quickly check back. What is the, how much data we do have in in credit card. Okay, so let's get credit underscore card dot shape, and this is, we are going to get that. So we have approximately, sorry, this is credit data dot shape. So we have these many rows, 284807, but we have only got 10,000 rows imported on data IKU. Okay, and we have 31 columns. So now what am I going to do? I'm going to sort my data frame. I'll write that over here. sort the data frame in descending order using the column class. Okay, so that we are going to get mostly the one values we will get, and then we are going to import that data over our server. Okay, so that at least we have enough number of cases so that we can perform the analysis. Now, so how will you sort? We're going to use credit underscore data. Okay, so there is a function known as sort values. You can sort the values. Sort value is a function in which you can provide name of the column. So you can give a by column. By could be a string or it could be list of strings. These are the column names by which you want to sort your data frame. And then you can specify, do you want to sort that in ascending order or in descending order? So we are going to say ascending is equal to false. Ascending false will make our descending active, and we are going to get the one values right from the starting of the data, followed by the zero values. And there is another feature known as in place. In place, what it can do? It can actually replace the sorted values in the current data frame. Okay, so let's do that. We are going to sort by class. You have this column class. Okay, we are going to sort by class, followed by ascending. Ascending is equal to false, which means we want to perform descending, and in place equal to true. So if you do in place, automatically the data will be modified and it will be saved into the current data frame. If you say in place is equal to false, then what happens? You are going to get a new object for the sorted values, and you can store that in another data frame. Okay. So what I can do is, let's do that. So instead of saving it into the current data frame, what am I going to do? I'm going to call it as sorted credit data. Okay, I'm going to call it as sorted credit data. So I'm going to call sorted credit underscore data, and I would like to get the top 3 values just to ensure that we are getting ones in the column, ones before. Okay, in the class values. So I've got a message class. He says key error, class is not found. Okay, just let us just check the columns. Credit underscore data dot columns. Maybe the class would have been written in a uppercase, maybe. Yeah. So the class key is written in uppercase. Hence, we got a key error because I have specified the small class. So let's change it. We're going to change the column name as class, and let's run it. So once you run this, now you can see that you have got these values loaded, and we have got ones here in advance. Okay. But there is one more problem happened once you have sorted it. You have got your indexes changed. Okay. So this could be a big problem when you upload the data or when you process the data. So now what you need to do, when you replace this, okay, you also need to sort the indexes. Okay. There is one more option which is known as sort index. Okay. Not getting that here. But let's just test that. Okay, sort index. Yeah. So now when I sorted index, you can see that I've sorted the indexes also. So we got the values, but these indexes are now changed into 0, 1, and 2. So now you can perform analysis and you can use your data frame. Otherwise, you would have been getting errors like the indexes are not labeled or the indexes are misarranged or misformed. So you have to overcome such problems when you work on these kinds of data. Okay. Now, so let's quickly observe. Have we got ones? No. I'm so sorry. Let's do one thing. So we sorted that. Okay, one. thing we need to do is when you sort this, you can replace the index. Reset index is the function. Okay, function is reset index. I'll just quickly check back. In a next cell, I'll check. This is known as sorted credit data and reset index. Let me just check the function. I actually forgot the name of the function. So yes, we do have this reset index. Okay. So this will reset the index or a level of it. Reset the index of the data frame and use the default one instead. Okay. So now what you are going to do, let us just use the reset index over here. So I'm going to call reset underscore index. And now once you run, we're going to get the index sorted now. Okay. So you're getting that this was the previous index in the data frame. And now you have got a new sorted index 0, 1, and 2. Okay. And at the end, you guys also have the values of 1 in the class. Okay. Now, so you have got this value loaded. I'll do one more thing before I transform it to the index, before I send it for processing on data IKU. I would also like to delete the column, okay, from my sorted credit data. And the name of the column is going to be index. I want to remove that. Okay, so now the index is gone. And if you go to the next cell, and this time if you check sorted underscore credit underscore data dot head, and if you get the top 3 values, you're going to get the indexes appropriately, all the parameters like time and variables, followed by the class with values 1. So this is how you can quickly perform this. You've got the data. Now what am I going to do? I am going to export this data frame into a CSV file. Okay. So once we export this data into a CSV file, we can take this to our data IKU and we can start pre-processing it. Okay. So let's call sorted underscore credit underscore data. Okay. And there's a function known as toCSV. You can quickly save that into a CSV file. So once you save that into a CSV file, you can quickly see that this is the function. You can save that to CSV file where you have to specify path of the file. Then you have to specify the separator. Okay. So comma is the default separator in our data frame. Just we need to specify the path where do you want to export it. Okay. So what I will do, let us just quickly save it as sorted credit data .csv. So I've given a file name where I'm going to store my updated information, and then I'm going to upload it on our server. So I've clicked on sorted credit data.tocsv. The file is running, and here under the files at the left hand side, you're going to get this CSV file loaded. Okay. So as soon as I ran it here, you can see that we are going to get this file loaded. Approximately 150 MB of CSV file has been created. Sorted credit data.csv. Okay. You can right click here, you can download this file of 150 MB and you can upload that onto the server. Okay. So what is going to change the percentage of fraud transaction? So we are going to have more information about the fraud transaction. And yes, it's better because now if we have to perform the analysis on credit card on data IKU, we will be having more number of fraud transactions. So that will be better for us. And once we get to know a relative algorithm, then we can again come back to a Python code and we can start analyzing over the complete data. So the data which is available over here, this sorted credit card data, this is the complete data. Okay. We have all the 24, 248, 807, whatever number of transactions were there, all data is available over here. But when I'm going to upload it on this, when I'm going to upload it on data IQ, when I'm going to upload it on the data IQ, then what will happen? We are going to get only 10,000 transactions over there. Okay, so it should be 1.72% according to the research. So it's not mandatory that the data of the fraud transaction should be 1.72%. No, it should not be like that. वहाँ पे लिखा होगा in the original data they would have the transactions 1.72%, but it's not mandatory. For a good model, you should have as much data you can have. You should have that for performing machine learning. And another message: still we are not using all the transactions. So still we are not using all the transactions. I didn't get that. What do you mean by this? Okay, so let the file, only 10,000 entries are uploaded to DSS. So yeah, only 10,000 entries will be uploaded to DSS. So we are just going to have an idea about what algorithms works relative to the data. And once we get them, we are going to perform our analysis on our Google collaboratory data with all the number of transactions which are available in data. Is that clear? Okay. So let's this get downloaded. So once the data gets downloaded, we are going to upload that on our DSS. We are going to have 10,000 transactions information. Moreover, what you can do is you can have three data sets. You can split this into 3 CSV files, and you can upload all the 3 CSV files there, and then you can perform analysis individually on the 3. That also you can do in case if you want. But that doesn't make any difference. We are going to have 10,000 transactions, and that would be sufficient for us to analyze the data, just to get an idea about what kind of algorithms are working best on that. Okay. And then we will see what algorithms are being used in the research paper. So it's downloading. Once the download completes, okay guys, so here the download is about to complete. Once we get that data, we're going to upload that on our credit card data set, as well as I would also like to upload that on our manager's card so that you all will be able to access it. So both ways we will do. So here you guys have got your data downloaded here. 150 MB of data is available over here in the downloads. And let me just quickly upload that on our Trello card. Let me see if I am able to upload 150 MB of data here. Otherwise, what I'll do is I'll upload it on my cloud server, and in the next session, you guys will be able to access that. I would have got that downloaded in my downloads section, sorted credit data. So let's open that. Again, it will take some time, I believe, in order to upload the data here over. So what we can do is, once the data gets uploaded, we will resume our program and we will start analyzing our data over DSS in order to identify what model works best. And then we will continue with identifying the algorithm, performance tuning the model, reaching to the highest accuracy in order to grab the fraud transactions effectively. And then we are going to make a product out of it so that we can deploy the model with the real-time financial companies, and we can give them more insights about how appropriately frauds can be identified. Moreover, I will be sharing certain resources with all of you. I have collected a pool of resources on credit card fraud detection for your reference, so that you guys will be able to identify much information about various ways of how credit card fraud transaction analysis are done, what all different kinds of methods are there. Okay, so for your presentation, I will be sharing. I have approximately got 29-30 links for credit card fraud detection, which you all can use. So here you can see that there are certain options, like from MIT, there are various articles on that, so that you guys will be able to work out on the projects and an effective model which we guys need to design in. We will be doing that in our current project which we are going in. Okay, so I'm going to share this link with all of you so that you all will be able to understand what type of products are being developed when it comes to credit card fraud detection, and how our product is going to be effective, and how we're going to use that product so that financial companies can utilize that model and they can work out on understanding how fraud is to be detected and prevented. So that's all for the day. Thank you so much for being available. Let's catch up in the next session. Thank you so much for watching.